Did you pick up on it?
Yeah.
Square it, add it. There's a shortcut to these. When you are working with difference of squares, when you're working with a difference of squares, because your conjugate would be 9 plus 4i. When I FOIL that out, I'm going to get 81 minus 16i squared, which becomes 81 plus 16. If I go through and look back at all the other ones that we had, 1 squared plus 1 squared was 2. 1 squared plus 2 squared was 5. I thought we had another one for that. But yeah, really, all that you wind up doing here, as far as shortcut is concerned, if you want to do that, first term, last term, add them together. Square them and add them together. It works every time. It's a nice shortcut. So your denominator here becomes, what is that, 97? Numerator, though, unfortunately, there is not a shortcut. You actually have to go do the math. Sorry. Bless you. Bless you. So when you FOIL that out, we're going to get a negative 63 minus a 28i plus a 54i plus a 24i squared. Now I know that plus 24i squared becomes, very good, becomes negative 24. So I have a negative 24, negative 63, which gives me a negative 87, plus, what is that, 26?
Yeah.
All over 97.
Wait, is the end of that a negative 24?
Yeah, I turned the 24i squared into a minus 24. Now, if those of you guys that came around and looked at the Big Book O answers, I'll get you guys 1 second, all right? If you guys look at the Big Book O answers, a lot of times what this book does, like I said, it splits it apart into 2 fractions. Don't waste your time. The only time I'm going to ask you guys to simplify these things out any further is if like they're all divisible by 2 or 3 or something like that. That's when I'll worry about it. The rest of it, nah. Okay? On this one, or let me get these guys and I'll get back to you then, okay? Miss Lori.
That's what I was going to ask. Like, if they're all divisible by...
Yeah, then we simplify. I have a couple, I think there's a couple examples of that coming up here that I'll show you as we go through, okay? Oh wait, roll, you went 63, right? Yeah, that's what, I forgot. 63 is the exact same thing. The only thing you have to be concerned about now, when you multiply your conjugate just happens to have a root in it as well. So you multiply it out, you're going to get 6 plus I root 2 over 6 plus, oh, I'm sorry, 6 minus, excuse me. So if I FOIL out the bottom, everybody agrees that it goes away, right? The middle terms go away. And then you're going to wind up with 36 minus I squared times root 2 squared. Well, what's root 2 squared? What's I squared? So I wind up with 36 minus a negative 2, otherwise known as 38.
So you have to break apart the I and the square root? And then
Because you're multiplying these two together. This is the same thing as if you had 3x quantity squared. That means it's 3x times 3x, so you get 9x squared. Works the same thing if it was with the radicals as well. Okay? Works the exact same way. Now I FOIL off the top. Yeah, Miss Lori?
So first you multiply like the same term. So first you do the 6 times 6, then you do the I times I, then you can do root 2 times 2.
Yep, because you got square root of jump times square root of jump, you get jump. And also notice, first term squared, 36. Last term squared, well, what's the square root of 2 squared? 2. And then it's an I squared, which becomes negative 2, so that's where we get it. So if I FOIL out the top, then I'm going to get 36 minus 6i root 2 minus 6i root 2, so I get minus 12i root 2. And then again, I have a plus I squared root 2 squared, which in essence is negative 2. And Lori, this is going to be an example of what you were asking from the last question about how you can simplify. Combine my like terms here, I get 34 minus 12I root 2, and it was all over 38. All three of these guys have something in common. They're all divisible by 2. So you can simplify everything by 2. And you get 17 minus 6I root 2 all over 19. And you call it a day. A day. Yes, sir.
Now, if it was on a test, we could simplify it and work it off.
Yeah, because you're not done.
Wait, what is that?
Bless you. What else we got? Yes, ma'am. Back over. All right. Good.
What was on 5-1?
Quiz old book. Quiz old book.
So, going back to what we've done so far, we've basically done these 4 sections. We've actually flown through them a little bit quicker than I anticipated. I thought would take us an extra day here, which is fine. There's nothing wrong with that. The 5-1, if we start with the 5-1, that was graphing. Wasn't a quick graphs, this is all quadratics. We have not done 5, 6. We had that as our first format for graphing quadratics. We called that standard form. We had a, b, and c, where ax squared plus bx plus c. When we worked with that, it was the most generic way of writing out quadratics. This was the first way you guys all have done it in the past. In this format, when you had them written out, you were able to identify your axis of symmetry first. Your axis of symmetry for these things were always x equals the opposite of b over 2a. From that, you were able to figure out your y value. Because, bless you,
Thank you.
because your axis of symmetry, your vertex always lies on the axis of symmetry. So this means that your vertex has the ordered pair of whatever opposite of b over 2a is, and y. And in order to figure out that y value, you take this number and you substitute back into here. That's all it was. A lot of plug and shove. After you did that, you were able to tell me whether or not it was a maximum or a minimum. How were you able to tell if it was a max or min before you really did anything? Good. Value of a. If a was positive, it was up like a cup and it was a minimum. If a was negative, it was a down like a frown and it was a maximum. Very good. That didn't change for any 3 of those types of equations that we talked about. Standard form, intercept form, or vertex form. I always forgot what it was called. The a value is all it did. The only other part of this then was a matter of getting those other values. Once you had your axis of symmetry, it was just a matter of picking a point to get the symmetric twins. Remember that? Relatively straight. It was very, and what I thought for you guys, after coming off of all those word problems and stuff where the algorithm, there was really no standard algorithm to solve the problem, these things, do this in this order, in this sequence, and you're going to get it right. That's where a lot of you guys are like, oh, sweet, I can do that. Okay. Miss Lori.
Can you go over how to do it in
I'm about to do that one next.
Okay.
Vertex form. Vertex form was a new format for you guys. It was another introduction or a reintroduction to the H and K. We talked about H and K when we looked at absolute value. The horizontal and the vertical shift of where the V met, the absolute values. That's the same basic principle here. Where this value of H and K is your vertex. Bless you. And the axis of symmetry is at x equals h. Now, here again, the A value tells you up or down. It'll tell you if it's a max or a min. And people have been asking me, well, what if the A value is 6? What does that have to do with the graph? Well, remember, when you're working with quadratics, the larger the absolute value of your A value, the tighter the curve is. So it just means it's a tighter curve. If it's a smaller absolute value, it's closer to 0, it's a wider curve. That's all the A value tells you in these types of things. That's it. You're just substituting in numbers to get your X and Y's. It's just plug each other back. Okay? Yeah? Oh, there you asked something. Good, I didn't want to answer it.
Is this still like if A is positive, it goes positive?
Yes, ma'am.
For all of these?
Yep. Yep. It's a nice thing to remember for these things. The axis symmetry gave you that. Now be careful. When you're when this is written out, y equals 1/2 x plus 4 quantity squared minus 3. Where's your vertex? -4, -3. Good. Because it's always opposite of h, same of k. So it'd be at -4 and -3. Okay? It's always like that. Think about when you had point slope form, y minus y sub 1, x minus x sub 1. If your ordered pairs were -3 and 2, it would have been y minus 2 and x plus 3, that kind of stuff. Okay? And the last one, which I thought was the easiest, is the intercept form. Again, A value here shows you what direction it's going, up or down. The P and Q stands for the x-intercepts. It's where you're crossing the x-axis. So P and Q are the x-intercepts. It's the zeros of the function. When you factor a quadratic, you're left with two terms. Well, if it's x minus 2 and x plus 5, that means your zeros are at 2 and -5. Those, since they are on the same horizontal spot from one another, they are always going to be symmetric twins. Which means what occurs halfway between the symmetric twins of P and Q will always be your axis of symmetry. Your axis of symmetry is always going to be at x equals P plus Q over 2. It's always at the average of it, whatever your P and Q are, always. Which gives you your x coordinate for your vertex, which means you substitute in to get your y value. Graphing quadratics is one of the easiest things that we can do, believe it or not, because everything is quite literal. Do this, do this, do this. There's not a lot of gray area here. Miss Lori.
So you only do symmetric twins in this form?
No, all of them have symmetric twins. What I'm saying is that when you have intercept form, when you have something given to you directly as an intercept, let's see here. Let's see if I can make one up real quick. Y equals -2, x minus 3, x plus 5. If I have a problem like this right off the bat, I have zeros at 3 and -5. Do you agree with me on that?
Yeah.
So I would go -5 and 3. What's halfway between 3 and -5?
4. -1.
So let's see, 3 and -5 is how much?
8. Oh, the difference is 8.
So you're going to be at -1. Okay, bless you. So you have your axis of symmetry is that x equals -1. Oops. So since the axis of symmetry is that x equals -1, these two are 1 little, 2 little, 3 little spots, 4. 1 little, 2 little, 3 little spots, 4. They're both 4 spots away from the vertical, or from that axis of symmetry. Therefore, these two are already twins. Whereas the other two formats, you are starting out with just a vertex on the axis of symmetry. Then you would just pick this next point to find the one over here. Find this point to find this one over here. They're starting you with a twin. You're working up from it. Okay? Yeah?
Then how do you find the vertex?
From this one? Same way. Once you get the axis of symmetry, that's your x value for your vertex. You just substitute in, and it spits out the y value. You find the vertex for all of these the exact same way. Once you get that axis of symmetry, it's always the x coordinate of your vertex. The rest of it falls in from there. Okay? What?
I love this stuff. I love this.
It's easy.
Yeah. That's so easy. Which I just did. I just didn't know. How many questions in the quiz?
I don't know, like 10?
How many gaps are
I don't know, 16.
on? You're good math.
SMRT is right. That's all there was for graphing. It was quite literal, just plug and chug. 5-2. Factoring. And yeah, we've kind of been doing factoring for the past 3 sections, really.
Yeah, because I was like, wouldn't we just do that like?
Yeah. And it's kind of the idea here is, as we get going into factoring, we factor in 5-2, we factor in 5-3, and we factor in 5-4. The only thing that changes up with 5-3 is that you're able to take square roots of both sides. It's a little bit of a shortcut. It's possible. In 5-4, you're still factoring in solving for zeros, but yet when you do those square roots, sometimes you're taking a square root of a negative, which gives you imaginary numbers. But the process for all three of these sections this week, they're all kind of the same. You know, what is always your first rule of factoring though? GCF. Always look for the GCF. Factor out the GCF and go for it. Now, what's the difference between factoring and solving? What do the problems look like? Yeah, solving has an equals. Solving has an equals 0 or equals like 6 or -14 or something like that. Factoring, which just says factor. What are the factors? The rest of them will be find the zeros, solve for x, things like that. What is the x-intercept? All three of those things kind of mean the same, except factoring just means what are your terms? Solving for zeros means you take it that one step further. Okay? Okay, I don't know what's going on, but okay, great. All right. Question. What type do you want to look at? Miss Lori.
Oh, wait, we're doing factoring?
Sure, what do you want to look at?
Oh, no, never mind.
Or anything from 5, 2, 3, or 4.
Okay, 5-3.
5-3.
When you have 7/2, and you have the square root sign over it, but not over both, it's just over the whole fraction. What do you do?
7/2, like the square root of 7 halves?
Yeah.
Okay. The square root of 7 halves. Yes.
Is this in 5-3?
Yes, this is 5-3. When you have to simplify a radical that has a fraction, what we want to do is rationalize our denominator. And in order to do that, first thing we do is we rewrite it as the square root of 7 over the square root of 2, because that's all that means. Now, in order for us to get rid of the radical in the denominator, we have to multiply the top and bottom by some factor of 1. And we also want to multiply it by something that will eliminate the radical. So square root of junk times the square root of junk is always, what's the junk in this case? Root 2. So I'm going to multiply the top and bottom here by root 2. Square root of root 2, I'm sorry, square root of root 2, that's the fourth root of 2. We don't want to do that yet. Square root of 2 times the square root of 2 is 2. Root 7, root 2 is root 14. And you're done. because the square root of 14 cannot be simplified.
So you always multiply by the denominator and the denominator?
Yep. Works the same way if you had to rationalize it. Let's say it was 7 over 2 minus the square root of 3. Think about what we did yesterday. What did we multiply by?
So the opposite sign.
Yeah, you multiply the conjugate. It's the same exact process. 2 plus root 3, 2 plus root 3. And think about what we did yesterday. Now there's no I involved, but you get 2 squared minus root 3 quantity squared. So you're going to get 4 minus 3. And then in the top, you're just going to wind up with 14 plus 7 root 3, and you wind up with 14 plus 7 root 3 as your final solution. Okay? That's all it is. What's that? See where I go? Just jump there. Root 3 and root 3 gives me 3. Okay. It's a little bit different with the I, because the I, you can't do that shortcut I showed you because I squared is what would change the sign. Here, since there's no I, you can't change the sign. It's just first term minus second term. Both this way. Yeah, it's 1. Math is hard. What else, guys? Yeah. Sure. Factor. Actually, I'll even turn this into a solve for your zeros. Because if you have to do all the same stuff anyway, you might as well do the next step.
I can still see it.
Hi, how are you? Good to see you. What do you do when your leading term coefficient isn't 1? Correct, but what's the first thing you should do, Lori? GCF. Always check. Always check before you get too far into it to see if you have a GCF. Do we have one? No. So now we multiply the tails. What's 6 times 5?
30.
30. What times, convenient, but put that there. What times what's 30 you add together to get?
15 and 2.
Very good. Does it matter which one goes first?
No.
Nope. Now, what I've done here is I've turned my trinomial into a quadrinomial, the 4-term part. Since I have an even numbered of terms now, I'm always going to try to group. So I'm going to try and see if I have a GCF. Hey, I do. 3x. And I have a 2x plus 5. Now, some of you guys, when you got to this part earlier, you got a little messed up here. Those guys don't have anything in common, do they? So what do they have in common? 1. If nothing is in common, you can always factor out a 1. Now I'm looking at my 2 terms that I have now. Are these guys the same?
Yes.
So basically, in essence, what I'm doing is I'm taking out the GCF of 2x plus 5. That's really what you're doing. And what are you left with? And then that would be your done answer for factor. What are the factors of? What then would be your answer if it was solve for your zeros? What would it be?
Negative 1/3, negative 2.5.
Negative, oh yeah, 2.5, or you can say negative 5 halves. That's all it is. You're done. That's it. That's it and that's all. That's all she wrote. Murder she wrote. That's Angela Lansbury. Is she dead? Hey Haley. Angela Lansbury, dead or alive? I think she's dead. She's from a show. She's a lady. She was an actress. She was on the show Murder, She Wrote.
Wait, what was her name?
Angela Lansbury. I bet you she's dead.
Mine top.
Am I right? Does that help the factor?
Yeah, I just want to make sure I have it. No, it says she's here.
Not dead? She's 90? Huh. All right, Angela Lansbury, ladies and gentlemen. Angela Lansbury's 90 years old. She's not dead. What else we want to look at, guys? We got a couple minutes, then we give you some props.
Some problems.
There are a few props. I don't care if you do them or not. It's up to you. I don't know. You want to walk through that again?
Yes.
All right. Let's walk through the powers of I. Real quick, let's walk through the powers of I. I have the power. No. No, that's right, He-Man. That's what you said. I couldn't remember who it was. So I, what does I equal?
Imaginary number.
It might be. It's the square root of -1.
Wow, good job.
Therefore, I squared would be root -1 times root -1, which is 1. Then I cubed is
I.
-1 times root -1, so it is negative I. I to the fourth is I squared
Is 1.
1. After that, it just repeats itself.
So this goes to 1 and then negative. Wait, so then it's just -1, negative I, 1.
Yeah. It's root -1, -1, negative I, 1.
Wait, so
It is.
I to the 5th is negative I.
I to the fifth is I to the fourth times I. I to the fourth is 1. I is the square root of -1, so it is just I.
That's what it repeats.
Yeah. So if I ask you, what is I to the 31st power? So think about it. How many? Divide by 4. It's the easy way to go about it. How many times does 4 go into 31?
7.
There's 7 of them. How many are left?
3.
So this is the same thing as saying I to the third, which is negative I.
So basically, you just have to know all of the other ways.
What's that?
Why is it negative? Yeah, why is it negative I?
Because 31, if I,
Just the third.
oh, I is the square root of -1. If I square that, I get negative. The square root of junk squared is junk. If I multiply that again by I get just negative I. Okay? If I multiply it again by I'm going to get negative I squared. Remember yesterday we said I squared was -1. What's -1 times -1? Positive 1. And the pattern repeats. Hey, I got a good one for you. Pete and repeat were in a boat. Pete fell out. Who was left?
Repeat.
Pete and repeat were in a boat. Pete fell out. Who was left? Pete and repeat were in a boat. Pete fell out. Who was left?
No, because then we don't have to do anything. Repeat.
Like I said, to review.
Oh.
Oh, I totally
Good conversation.
So it's either
Been a long day.
okay. So like if there's like 1 left which we divided by 4, then it's just equal to like I.
Yes, it's just I to the
And
first
then
power.
if there's 2 left,
It's I squared.
Yeah, which is -1. And then if there's 3 left, then it's negative I. And then if there's 4 left, then it's just like
1.
yeah. Do we need to go to that?
Technically, no, because you can always write, guys.
Like on the
I don't know. You're gonna hate me when you start asking questions about tests and quizzes. You can ask those other bozos. I don't tell you anything.
Bozo.
Hi, Lori.
Oh yeah, and don't waste your time on going into flex before a quiz because he won't help you. So.
Well, 12th hour is you have a disadvantage. Well, it's an unfair advantage for second hour. That's all. Well, you guys.
Yeah,
that's true. They still have.
That's fine. No. No.
But don't they still have one more flex?
Yeah.
Class?
Nope, because you guys still have that same flex thing, and you both have the morning before.
Well, we don't have
But
flex
they're-
tomorrow anyway.
So.
They only have one.
Laura, you can ask something.
Can you go over how to check the points for graphics so that you can like plot the two different?
Yeah, once you get a vertex.
Yeah.
So if I go back to the one I had. Hey guys, give me a second here, please. If I go back to the one we had, we found the axis symmetry at -1. To get the vertex, all I'm going to do then is take -2 times -1 minus 3 times -1 plus 5. This is -2 times -4 times 4. 32. It's up there, okay? And now the next one I'm going to pick, yeah.
Oh wait, so what if that happens? How would we like show them?
I try to make sure I give you stuff that fits.
All right.
If it's like a 12, I can get you can fudge it a little bit. If it's like 30, I try not to do that to you. Remember, I just made this up really fast, okay?
So if we get 30, then
So,
it's not.
you never know. Now, that gives me, what did I say it was, positive 32? There's my vertex. Now, the next number I'm going to pick, since it's my axis of symmetry is at -1, I'm going to pick 0. What's 0 minus 3? So I'm going to have -2 times 0 minus 3 times 0 plus 5. So it's 6 times 5, which is
30.
So at 0, it's up at 30. At -3, it's also at 30. That's all I'm doing. I'm picking, once I get the axis of symmetry in my vertex, I pick numbers to either side and just plot them. That's it.
We have to use the -3.
What next? That's up from here. From the original equation. I'm plugging chugging from the original equation. That's it. Okay? Let me give you guys the stuff that I have for you. What I do.